Hello, students. So, now this is the lecture on exponents. Okay, so the lecture on exponents or indices. Indices. Okay, in this lecture, the outlines are like this: the positive and negative integral powers, how we are going to solve them, how our different identities, laws, formulas are there which we can imply and to solve our or to simplify our questions. And the rationalization, rational exponents or a real number. Okay. And the laws of rational exponents. Okay. Uh, moving on to right onto our first topic, the positive integral powers. Okay, so positive integral power, uh, so as the name suggests, it the power meaning, if I have a number of base and there it is base and it is some n means number of times a is multiplied to itself, and it named as exponent or indices. Okay, I hope this is clear. Let me give you an example. So if you multiply 2 times 2 times 2 uh, by itself to 3 times, so I can rewrite it as like in this form. It is exponent form, and here 2 is base and 3 is our exponent. Okay, I hope this is clear. If 5 to power raised to the power 2 is written, so it means 5 times 5, which is 25. Okay, I hope this is clear to you. Now, as a positive integral power, so the our n, here we are talking about n is positive, and from integer. Okay, so n can be 1, 2, 3, and so on till infinity. Okay, so let's see another in deep. The n we defined as an as a raised to the power n, that is a multiplied n times. So a is multiplied by itself n times. Okay, so okay, I hope this is clear. And a is called as the base, n is called as the exponent. Okay, exponent. So the example which I have already given, 2 cube means 2 times 2 times 2, which is equals to 8. 2 times 2 is 4, and then 4 times 2 is 8. Okay, I hope this is clear. Let's move on. Now there's a note that if a we talked about a raised to the power 1, which is a raised to the power 2, which is a into a cube, which is a into a times a 3 times, and so on and so on. Okay, now, okay, what about a raised to the power 0? So the note is given here. So if a is non-zero, a non-zero means a not equal to 0. Okay, a is non-zero, we define or we say that a raised to the power 0 is equal to 1. Okay, so from an example, let's see that 3 raised to the power 0 3 raised to the power 0 is equals to 1 from this note. Similarly, a by 4 raised to the power 0 is also equal to 1, but we don't know 0 power 0. Okay, so we don't know, or we don't talk about here. Okay, we don't know. Because a must be non-zero. A non-zero means a not equal to 0. So 0 power 0 we don't know. Okay, keep this thing in mind. Okay, uh, let's move further. Now, okay, let me give you a little proof that a0 is 1. Why? So I can write a0 as a 1 minus 1. Okay, I hope this is clear. And a power 1, I can break it down like this, a minus 1. You will see this holds. It is true. I can do that. Okay. Now after this, we know a minus 1 is 1 upon a. Okay. You will see this also. For the sake of proof, just be with me what I am doing and do some assumptions. Okay. Then I can say a1 by a1, and I know this and this is both are equal. So if both are equal, then it will cancel out. Then only remaining thing is 1. So we say a raised to the power 0 is 1. Okay. 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 And this is true only when a not equal to 0. So that's why we said that for non-zero a, we have a not equal to 0. Okay, I hope this is clear. Now let's move. Now the negative integral power. Okay, the negative integral power. So the negative integral power is, now we talked about the positive powers for like a1, a2, a3, a4, and we talked about a0. Now we are talking about negative powers, for example a minus 1, a minus 2, a minus 3, and so on. Okay, so as I have already given you a simple proof or simple logical reason to the previous note, that a0 is 1, in which I have used a minus 1 is equals to 1 upon a. So now here what I had used was the negative integral power. So negative integral power. So we define a minus n is equals to 1 upon a. For example, 3 minus 2 is equals to 1 upon 3, 2, which is 1 upon 9. Okay, I hope this is clear. Okay, now let's move. Okay, so keep one thing in mind, that a is non-zero here. Okay, in the previous note we emphasized that a must be non-zero. So here also in negative integral powers a must be non-zero. Okay, I hope this is clear. Let's move. Now we'll see the rational exponent, or okay, on a real number. Okay, so the exponents are of form rational numbers. Previously we talked about integral powers. Integral powers, we talked about negative integral powers, we talked about positive integral power, and we talked about power when the power is equal to 0. Okay, now we will talk about rational. So now first thing is to understand the principle of nth root of a positive real numbers. So what it says that if A is a positive real number, A is positive real number, that means A is something like 1, 1 by 2, 1 by 100 or 1000, okay, anything like this. Okay, positive real numbers means A is strictly greater than 0, and n is a positive integer. N is also positive integer, so n is positive integer, that means n can be 1, 2, 3 and so on till infinity. It can be anything. Then the principal nth root of A is unique. Do remember this, it is unique positive real number x, such that what it says that x raised to the power n is equals to A. Okay, I hope this is clear, or let me take an examples to make it more clear. So the principal nth root of a positive real number A is denoted by this or this. So here we are talking about uh, for example, uh, taking n equal to 2 and A equal to 4, then the principal square root, the principal square root of a positive number A, which is 4, is denoted by this. That means 4 raised to the power 1 by 2, or 2, 4. We know what is the answer. The answer is 2. So it is unique number. So the answer for this is as it is given here, it is unique positive real number. So 2 is positive here and it is unique, and if you see that the x is comes out to be 2, and then if you apply this thing, it will hold. That is 2 raised to the power n, which is 2, must be equal to A, which was 4. We know 2 times 2, which is 4. Yes, it is true. Okay, I hope this is clear. Let's move on to next. Now, second, the principle of nth root of negative real numbers. We talked about the positive real numbers. Now we are talking about the negative real numbers. Okay, in here we talked about positive. In here we will be talking about negative. So if A is negative, okay, A is negative real number and n is odd positive. Keep this thing in mind, n is odd. Then nth root of A is defined as this. Okay, what is this symbol meaning? It is modulus symbol. It is modulus symbol, meaning it gives any value, or it is a machine which gives a positive output. That is, if I have -3 and I apply this modulus, then the answer will be 3. If I have 3, then the answer will be 3. If -1 by 2, then I apply this modulus machine or modulus symbol, it will give me 1 by 2. Okay, I hope this is clear. Okay, see, similarly here. Okay. So taking any negative real number, let's suppose A is -3. Okay, A is negative, less than 0, negative. Okay, now in this case we only take n as odd number. So take n as let's say let's take A as -27 and n as 3. Any odd positive integer. So n is odd and positive integer. What are odd integers? So odd integers are those integers which not exactly divisible by 2. So it is odd. Okay, and it is positive. Then the principal nth root of a is defined as, so the modulus of 27 1 by 3. I can rewrite as, so it will become 27 1 by 3, or it is cube root of 27. I know the cube root of, from the surds I can rewrite it as like this, and 27 is 3 cube, and we know from the law of surds that this, and if this is same, then the answer is only this. Okay, so it is equals to 3. So the answer will be our 3. Okay, I hope this is clear from example. So let's see our remark. If a is negative real number and n is even positive, we talked about if the a was 27 and n was 3. What about if n is even? Let's say 2. Let's see another example to understand this remark. If a is -4 and n is 2, that n is, it is even because it is exactly divisible by 2. Is any negative number? Yes, it is negative. Then the nth principal root of a is defined. A is not, keep this thing in mind, that in this case if a is negative and n is even, then we don't define nth root of a, okay, because any even power of real number is always positive. Keep this point in mind. Okay, this point keep in your mind, that any even power of real number is always positive. So we don't have any x such that x square is -4, because it is negative, and we know that any power, any even power, any even power of real is always positive. Okay, I hope it is clear that okay. So okay, now I hope this is clear, that it is any even power of real number is always positive, so it won't true in general. Okay, now if you see that okay, now it is good. Now therefore if you try to see this, the -9 of 1 by 2, which is meaningless quantity because we don't have any x such that x square is -9. Okay, 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 and okay, yes. Now one thing is there is some mistake. Sorry for that. Let me correct that. This must be LE. Okay, okay, the spelling mistake is there. Okay, this is the correct, this is not. Okay, this one is the correct spelling. Okay, sorry for that. I think someone made a mistake from the okay, let's move further. Now rational powers. So what about the rational powers? So if A is any positive real number and a rational number p upon q, and we are uh, taking a rational number p upon q where the q must not equal to 0, we defined a power p by q is equals to like this. Okay, if you see from example is let's see 9 and b sorry p by q let's say okay 3 by 2. Okay, so a p by q is equals to 9 raised to the power 3 by 2. Okay, so it says that 9 cube 1 by 2 is both are equal. Okay, and you can further solve it, like, because we know that if you try to see it from here, that 9 can be rewritten as 3 square, then 3 by 2, then using 3 square, I have already told this will get multiplied. You will see that this is there is some identity or law that we can multiply them. Okay, so we multiply, then it will cancel out, then we are left with 3 cube, then it is 27. Okay, so let's move further. So here are the some laws which we will use or we had already used. For example, this, okay, there is some mistake. This must be n. So multiplying a power m multiply with a raised to the power n is a raised to the power m plus n. If am is equals to a times till a, this is m times a. Okay, m times a is multiplied. In an, a is multiplied n times. Okay, if both are multiplied, that is am multiplied with an, then am can be rewritten as like this: a times till a. So the number of times a multiplied is m times. Now it is multiplied with a times a, which is n times. Now if I remove the brackets, so I can easily remove, then I can see the m times a are here, m times a, n times a are here. So total number of a's multiplying itself is m plus n. So I can easily say that a is multiplied m plus n times. Okay, so this is your first property. Now the second says that am divided by an. We know a divided by b, we can reciprocal the division sign is like into, we can interchange the division or multiplication sign with just using a reciprocal. Okay, so a times 1 by b, and we know a by b. Okay, or we know 1 by b is equals to 1, b raised to the power minus 1, as we saw in the uh, integral power with negative integral power. Okay, so if you see am, the division sign multiply with changed to multiplication, it reciprocal the this term, and this term is equals to, in term of exponent, so minus of n, and we know from the this that the powers get add. So 1 m plus minus n, m plus minus n, which is further can be simplified as m minus n. So this, so this is also very important, as you already saw I have used it quite quite often. So it says that a raised to the power n and whole raised to the power n, then we can rewrite it as like a raised to the power m multiply with n. Okay, I hope this is clear to you. Now let's see other laws. Now I have already told you about this, that 1 by a n is equals to a minus of n. Okay, and this is very important. All of the laws are very important. a raised to the power m by n, I can rewrite as a power m 1 by n. Okay, just these are not difficult to remember, but they are very, very, very useful in solving or making your calculations easy. Okay, we can interchange or play with our here we interchanged the powers, we played with powers, easy. Okay, or we know this, we can write as nth root of a inserts we have saw. Okay, from this nth root of am. Okay, we already seen this. Okay, and this there is some mistake also here, because ab raised to the power m is equals to, the power gets distributed to every element, so a gets this power, b also get this power. Okay, I hope this is clear. Let me take an examples each to make it understand better. So for this, if 3 minus 2 gives, then I can write as 1 upon 3 square, which is 1 by 9. Okay. For fifth, if 3, or I can say 9, 9 cube by 2 is given, so I can write as 9 cube 1 by 2, or I can rewrite it as 9 1 by 2 cube. Okay, so both all are same thing, and it is root of 9 cube, and this one is root of 9 cube. Okay, root of 9 cube, and here root 9 whole cube. Okay, uh, okay, so I think this is clear. For this, if 6 raised to the power 2 is given, that means I can write 6 as this square. We know this is equals to 36. We know from this law I can distribute this 2 to each of the elements. So 2 raised to the power 2, 3 raised to the power 2. I know 2 raised to the power 2 is 4. I know 3 raised to the power 2 is 9. And I know 4 times 9 is 36. And we know both are equal. Okay, I hope this is clear. Let's move on to next properties. Similarly here, if you saw the sixth property, the AB raised to the power m, the m get distributed to a and b. Similarly, here the same thing will happen. So a by b, the raised to the power is m. Now m, the power will get distributed to m and also to b. Okay, this will, if you take an example, the 4 by 2, we know 4 by 2 is 4 by 2. Okay, let's say 2. Okay, so we know 2, if you cancel out, it is 2 raised to the power 2, it is 4, or from this law we can see it is 4 raised to the power 2, 2 raised to the power 2, which is 16 by 4, 16 by 4, and we know it is 4. Yes, they both are equal, gives equal answers. Okay, if you see this, it says if a raised to the power bn, we know bn is equals to b times n, which is I can rewrite as b plus it is b is added to itself n times. Okay, n times b added to itself n times, so I can rewrite it as like this. Or otherwise, in other sense, you can see like if 3 plus 3 plus 3, 3 plus 3 plus like 2 times 3, then 2 times 3, I can rewrite it as like this. So in a similar way, I write this bn as b adding n times, and bn, which is now a b plus b plus b plus b till n times. And if you remember, a m plus n is equals to am an. Remember, I am using this property, so I can rewrite it as like a power b, a power b till a power b. How many times? N times. N times. Now a b, a raised to the power b, a raised to the power b, a raised to the power b is getting multiplied. So a n times. So I can rewrite it as a bn is equals to ab whole raised to the power n. Okay. I hope these all are clear. Okay. Let's move to next. Now we'll see, or we'll do some more examples or exercise to understand the topic better. So let's evaluate what we are given. So it is quite easy. 5 square times 5 raised to the power 4 is equals to, we know 5 square is 5 times 5, which is 25, and 5 raised to the power 4 is equals to 5 times 5 times 5 times 5, which is 4 times we multiply 5 by itself. So we know 5 times 5 is 25, we know 5 times 5 is 25, and we also know 25 times 25, which is 6 to 5. Yes, which is 6 to 5. Now just multiply both of the numbers. 25 times 6 to 5, you will get your answer. Or in order to, you can just present in a exponent form. If one is saying, if the question was evaluating means you have to calculate to the actual digit number, whatever the number is forming. Okay, whatever the digit number is forming. Okay, so it is quite big. I think 25 times 6 to 5, 25 times 6 to 5 is something like that, 15, 6 to 5, I think. Okay, or otherwise you can make it in a simple form, like using laws. We know a raised to the power b, a raised to the power, sorry, I'm not using b, m, and I know a is m plus n. So from this I use 2 plus 4, which is 5 raised to the power 6. If you do 5 raised to the power 6, you will get the same answer. Okay, this one. Okay, I hope this is clear. Let's move on to next. Okay, so, oh yes, this is our answer. Okay, let's move. Same, using just properties. So 5, I used a m divided by a n, which is equals to a m. So just this trick, you can remember what it equals to. Just use m and n. Here you see the minus sign, so just imply this. So this is equals to this. So you don't have to, in order in from this, using this, you don't have to remember that what sign comes here, plus, minus, multiply. So just use this. In division case, just take out the middle part and put it here. So it will become a raised to the power m minus n. So it is equals to this, and 5 raised to the power 5. So 5 raised to the power 5 is, one can easily evaluate by multiplying 3 to 5. Okay, I hope this is also clear. Now this. Oh, using the property, what property I am talking about? If am raised to the power n, then the powers get multiplied. So just remove the bracket and multiply it. Just remove the brackets and multiply it. Okay. So raised to the power m multiply with n. Okay, so this will gets to 3. So I am just removing. Now you are wondering what sign will appear here. So I already told you the minus sign will come when division is there. Okay. And plus sign when it will become, suppose a a raised to the power m multiply with a raised to the power n, then just write a m n, then this is multiplication sign. What it looks like uh, tilted plus sign, so we use plus. Easy. So we know when minus come, we know when plus sign come. Now the only sign remaining is multiplication sign. Okay, so the multiplication sign will come for this when nothing is given, or the just power, or just the brackets are given between two powers, just multiply sign. Okay, so 3 raised to the power 4, 3 raised to the power 4 is, one can easily say, 81. Okay, so let's move on to next. So we already know. Okay, there was some mistake here. The question is asking for 2 and 2, but the answer was for 3. So you try for this. Both are on similar laws. Okay, let's move on to next. So now 11 by 12 raised to the power 3 is given. So if this is given, the fraction is here. So the distribution of powers comes in mind. So a by b whole raised to the power m, then the distribution comes in our mind. So am, bm, just just it is just a distribution. Okay, so nothing. You can evaluate 11 cube, which is further equals to 1331, and 12q, which is further equals to, I think, 1728. Okay, okay, let's move. Yes, so just this. Now the power is given negative integral. So we know a minus n is equals to 1 upon a. Yes, we know a minus n is equals to 1 upon a raised to the power n. Okay, but here but here 3 upon 4 is given, so no need to be afraid. It is quite easy. Whatever the form is given, just follow this rule. So taking a is equals to 3 by 4, we have now a minus 3, then I can write as a power 3. Now what was my a? A was 3 by 4 raised to the power 3. So I can now distribute my number. I can now distribute by using this a by b m, which is a m b m, which further equals to 1 by 3 cube by 4 cube, which is equals to 1 by 3 times 3 times 3, which is 27, and 4 times 4 times 4, which is 64. And I know from the fractions that if 1 upon a by b is given, then I can rewrite it as b upon a, or if p upon q divide a big denominator, in denominator there is also a form r upon s, then this least so the value here will goes to the up, and the value of here goes to the here. So this will goes up, and 1 is nothing, so 1 remains there and 27 remains to their place. Okay, so the final answer would be 64 by 27. The other way you can try this is also like first distribute the power. So it is -3 and 4 -3. Now after distributing the power, so this I already know a minus n is equals to 1 upon a power n. So 3 raised to the power -3 becomes 1 by 3 and 1 by 4 3. Yes. Now 1 by 27 and 1 by 64. Now I can use the previously I told about this fraction p upon q and r upon s. So s goes up, q goes down. So 64 goes up. So 64 and 27 and goes up and multiply with 1. So here the s goes up and multiply with s and q goes down and get multiplied with r. So here 64 goes up multiplied with 1, 27 goes down gets multiplied with 1. So it will give the 64 by 27 only. Okay. So the answer still remains the same, 64 by 27. 64 by 27. I hope this is clear. Okay. Now I have already gave this type of questions. Now I'm just now the previously I gave you only this single example. Now the both are get multiplied. Okay, this kind of question. First let me give you how to solve this, and then after this I'll give you homeworks. Okay, so you try by yourself and understand the topic more. Okay, so to first distribute the power for every term. So distributing the power. Okay, 11 2 3 raised to the power 2, 3 raised to the power 3, 2 raised to the power 3. Now just if you try to see that now observe the now let's write in this form. Okay, so you can easily see I am just putting 2 below 2 and 3 below 3 so that I can easily, so 11 here I put 11 below 11, 2 here I put 2 raised to the power 3 to below to the 2 raised to the power 4, and similar with 3. Okay, so in this manner what I can achieve, I can make use of the formula. If you remember the formula, so what was the formula? So the formula says that a m divided by a n. So a m n. So what sign it comes? So here is minus, so I use minus. So if you see, I can rewrite it as like this: 2 cube multiply 11 square and 11 4 multiply 3 cube 3 square. So I can use the property here. Yes, I can. So I easily simplified my questions to like this. So 3 minus 2. Okay, so a m divided by a n, or it is equals to a m multiply by 1 upon a n, or a m by a n. All of the forms are same and is equals to a m minus n. Okay, so what I'll get? So I'll get 1, I'll get -2 here, I'll get 1 here. So just now simplifying more, 2 times 11 minus 11 raised to the power -2 is 11 a minus n, what it equals to 1 upon a raised to the power n. So 1 by 11 square times 3. So let me rewrite here 2 times 1 upon 1 to 1 times 3, which is further equals to 2 times 1 times 3 by 1 to 1, which is further equals to 6 times 1 to 1. Okay, I hope this is clear for you. Okay, let's move to next. Okay, so the answer is 6 by 1 to 1. Okay, uh, I hope this you can do it by yourself. It is for your homework. Please do to understand what depth you got your understanding of the concept. Okay, let's move. Don't rely on answers, the answer sheet you saw. Okay, so now let me do it for you. This, so we know am multiply with an, you if you see n, so what symbol I am going to use here is, it is multiplication, so multiplication is same as plus, so I use plus. So this will change to 55 plus 60, which is equals to 110. Okay, yes, is it? Yes, no, it is 115. Okay, now same for this, applying this is 2 raised to the power 97 plus 18. So 97 plus 18 is 115. Okay, it is also 115. Now I can easily subtract them because the base is same and the power is same. So whenever the base and the powers are same, both the things are same, so then only we can add and subtract two exponent numbers. So both are equal, so it is 0. Okay, note, when let me write in red so you can see. Note, whenever the base and the exponent are equal, then we can easily add or subtract our exponent forms. Okay, okay, do remember this note. Okay, let's move next. So this is the homework for you, so you try. Okay, let's move. Now let's do some simplification and make use of laws we had learned. Okay, so it is let's take one term at a time to understand it better. So 25 raised to the power 3 by 2. Okay, so it says that I can, if you remember, so 25 I can give 1 by 2 inside, or just don't do the long method. Let me give you a short one. So 25 is 5 times 5, you all know, and 5 times 5 is 5 square, and 3 by 2 is already given. If you remember, AMBN is given, so I can write it as like, I can write it as like a m times n. Okay, so power gets multiplied. So 5 2 times 3 by 2, which is 5 2 times 3 by 2. I can easily cancel out this. So 5 3, so 5 cubes. So it is just 5 cubes. Now 2 4 3. Okay, now 2 4 3. Now let's see for this. So 16 raised to the 5 by 4 is 2 raised to the power 4, 5 raised to the power 2. Okay. Okay. Now what we will do. Okay. So the 2 raised on similar laws, we can say 2 raised to the power 4 times 5 by 4, which is equals to 4 get cancels. So 2 raised to the power 5 is only left. So here the 2 raised to the power 5 only left. Now for this 2 4 3 raised to the power 3 by 5, if you see 2 4 3, if you see 2 4 3, it is 3 raised to the power 5. Okay, so 2 4 3 is equals to 3 times 3 times 3 times 3 times 3. Okay, which is equals to 3 raised to the power 5. So I can, it gets cancelled easily. So 3 raised to the power 3. So 3 raised to the power 3. Now 8 raised to the power 4 by 3. It is 8 is equals to 2 cube. 2 times 2 times 2. It is 4 by 3. 3 get cancelled. 2 raised to the power 4 is left. 2 raised to the power 4 is left. Now 5 cube by 3 into 3 cube by 2 5 2 4. In the denominator I use am, an and amn. So here is multiplication, I use plus. So it will get 5 plus 9 is 5 plus 4 is 9. So 5 cube times 3 cube. This is our answer. If you going to evaluate more, you can do so. Okay. Oh, okay. I hope this is also clear. Now this is now for your homework. I hope you will do this. This will give you the more understanding of this concept. Okay, don't use the answers, the solutions. Okay, now more exercise for you to solve. So let me solve solve for you. Now thank you for your attention, and I hope you learned new things from this session. Thank you.